Good day, Doctor. I'm Tharnisha and my matric number is A1-4. So today I'm going to present the introduction, project objectives, and also the scope of the study. So for the introduction, I would like to start with the definition or also what is power system. Power system is well known for its interconnected network that consists of components that converts non-electrical energy to electrical energy form and also distributing the electrical energy from generating sources to the load that is essentially important to deliver the electricity as economical and reliable. So generally in power system, the system response is essential as the source of harmonics. The property of a power system that allows it to remain in a state of operating equilibrium under normal operating conditions and also to regain in an acceptable state of equilibrium after being subjected to a disturbance. Is also known as a power system stability. So in power system, disturbances can be classified into two, which are small and also large. So small disturbances are often referred to the incremental changes in load and also generation, while large disturbances are referred to the loss of large load or generator and also transmission line fault. So, apart from that, power system stability can be divided into rotor angle stability and also voltage stability. In rotor angle stability, the synchronism can be maintained after a disturbance, while voltage stability is the ability to maintain the steady acceptable voltages at every bus after disturbance. So, the ability of interconnected synchronous machines in a power system to maintain synchronism after being distributed is known as rotor angle stability. So besides that, what is stability? Stability refers to a state of equilibrium between opposing forces. So the input mechanical torque and the output electrical torque are in equilibrium under steady state conditions. And also the speed remains constant. And the equilibrium will be distributed in the presence of disturbance. So voltage stability are referred when the voltage at all buses reach acceptable steady states levels and also by following a given disturbance and also system contractions, which is a criterion for the large disturbance voltage stability. So, the main scope of this laboratory activity is the analysis on the power system response for power system stability by using MATLAB simulating software to obtain the results such as the rotor angles, speeds, electrical power of the machines for each disturbance in the case of stable and unstable after disturbance be applied to the system developed. So we are having three main objectives to be accomplished by the end of this laboratory session, which is to model a test system model of power system using MATLAB simulating software, to analyze the dynamic responses of the system following a disturbance, and also to work in a group in order to solve the complex power system problems. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is A1-4 binti Wan Muhammad Zailani, matric number CE190 and 2. For this lab session, I will present literature review and methodology. MATLAB has become the industry standard for simulation and modeling. Simulink is a significant MATLAB addition that greatly simplifies computing. It allows users to drag and drop components into a new tab, join them and test the model. Simulink is an effective simulation model for examining power systems dynamics. It has a graphical user interface for generating block diagram modeling through drag and drop methods. Engineers can use MATLAB software to analyze a system in real time involving adding disturbance to the system. Harmonics are interruptions that happen in power distribution systems as a result of current wave and voltage disruptions. Next, methodology. Simulink is a multi-domain simulator and model-based design block diagram system. It provides embedded device systems integration, simulations, automate software development, and continuous testing and evaluation. It is MATLAB integrated, allowing to incorporate MATLAB computations into models. Next flowchart. We start to identify the component used in the circuit, then plan and design the circuit, apply disturbance in the circuit. After that, check the connection and simulate the circuit. If the circuit can run successfully, we can complete the report. If no, we have to recheck the connection of the circuit. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good morning to our lecturer. My name is SYED HASSAN HUSSAIENI bin SYED Omar. My matric number is CE 190050. So for today, I will represent or give a little bit of presentation about task that has given to me to get a simple waveform for the simulation at bus 9. Okay, so for accessing the bus 9 circuit, we need to go to the area 2, and this is our bus 9, and I have changed a little bit the circuit to get actual result. So over here I add 3 phase breaker. So the breaker condition is initially in a closed position for getting the result. So all of the load is following the specification that given in the lab sheet. So after we run the simulation, we get this result. So for the first one, we get the roto angle represent the normal condition of the model system prior to the sudden load decrement at bus 7 at time 1 second. After that, the roto angle waveform is marginally stable at time between 10 to 12 seconds of the simulation time, and return to the equilibrium after a load of 2 seconds, then showing that the waveform was stable after 14 seconds and above. So next is the roto speed versus time graph over here. As we can see, show that the speed waveform become unstable at the starting position, and indicating that the speed is decreasing with the respectively to the time at the end and the load change at the bus 9, and then represent the normal condition of the model system prior to the sudden load decrement at the bus 9 at the time 6 seconds, and showing that the waveform stable at the 9 second, at the 8 second and above. So the load decrement happened at the bus 9 at time 2 seconds, and showing that the waveform was stable after 8 seconds and above. So next one is the electrical machine power versus time over here, the upper right, and that showing the waveform begin to become marginally unstable at the starting point until 4 seconds, and the load decrement occur at 1 second at the time of 1 second, and return to equilibrium after 4 seconds. After that, the graph showing that the waveform was stable starting from the 4 second and above. Last one is voltage magnitude versus time graph, show that the voltage waveform begin to become marginally unstable at the starting point at 1 second time. After that, the voltage magnitude becomes suddenly unstable again between 1.5 second until 2 second. Then the graph finally was finally stable at the 12 second and above. So that's it from me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad SYAHMI bin Jeffrey, and my matric number is CE 180081. Okay, I will present about the discussion and conclusion. So discussion, we will make a discussion from the result that we get. So we get a 4 graph, which is first rotor angle versus time graph, generator speed versus time graph, voltage magnitude versus time graph, and electrical machine power versus time graph. Okay, so from the graph we can make 3 discussion, which is stable case, marginally stable case, and marginally unstable case. So for stable case, from the graph rotor angle versus time and generator speed versus time, illustrate the normal condition of the model system prior to the sudden load decrement at bus 9 at time 3 seconds, in which the waveform was stable and in the steady state range, as well as in proportional equilibrium on the graph of rotor angle, generator speed, voltage magnitude and machine power. In addition, the rotor angle graph reveals that generators 1, 2 and 3 remain stable and revert to equilibrium after time to 6 seconds, while 50% load decrease occurred at bus 9 at time 3 seconds. Okay, for marginally stable case, on the basis of the graph of rotor angle versus time and the graph of generator speed versus time, it can be observed that the waveform of both rotor angle and generator speed become only marginally stable between the times 6 seconds and 20 seconds during the simulation time, and that they return to an equilibrium state after a load reduction at time 3 seconds. Okay, the last one is marginally unstable case. Okay, the voltage waveform become marginally unstable at the point where time 1 second was when the load decrement of disturbance occurred at time 3 seconds, and it returned to equilibrium at time 6 seconds from the graph, which depicts the magnitude of the voltage versus time, and the graph which depict the power reduced by the electrical machine versus time. Okay, for the conclusion, MATLAB simulating may be used to easily simulate a two-area system according to the simulation. If a fault occurs on a particular bus, the system will become unstable. In addition, after a disruption, the dynamic reaction were analyzed. The result revealed there are three instances of stability in the graph. The three cases of stability are slightly unstable, marginally stable and stable. Moreover, the group solved a challenging power system challenge in a little amount of time. In conclusion, a fault can occur at any bus in a two-way system, causing it to become unstable, but it will eventually regain its stability. That's all from us. Thank you.